Ever wondered how AI gets better at solving complex problems, like math equations, logical puzzles, or even scientific reasoning? It's not just about feeding it more data. Today, we're diving into a groundbreaking technique that's reshaping how AI models learn: simultaneous reinforcement and supervised fine-tuning, SRFT. This method isn't just a tweak. It's a paradigm shift in training AI to think smarter, not just harder. Let's break it down. Let's start with the basics. Traditional AI training relies on two main approaches: supervised fine-tuning, SFT, and reinforcement learning, RL. SFT is like giving a student a tutor, showing them correct answers and teaching them patterns. But here's the problem. If you only show examples, the model might memorize solutions instead of understanding the underlying logic. It's like a student who crams for a test, but can't apply knowledge to new scenarios. Then there's RL, which is more like letting the model experiment. It tries different answers, gets rewards for correct ones, and adjusts its strategy. This encourages exploration, but it's tricky. RL can get stuck in rabbit holes, repeating the same mistakes or overfitting to specific cases. For years, researchers used these methods sequentially: first SFT to teach basics, then RL to refine. But that's like teaching a kid to ride a bike by first showing them a video, SFT, and then letting them fall, RL. It's messy. The model either becomes too rigid or gets lost in trial and error. Enter SRFT, a revolutionary approach that combines SFT and RL at the same time. Here's the secret sauce: entropy. Wait, entropy. That's the measure of randomness or uncertainty in a system. In SRFT, entropy acts as a balancing mechanism. It tells the model when to stick to what it knows, SFT, and when to explore new answers, RL. Think of it like a GPS that switches between follow the map, SFT, and explore new routes, RL, based on traffic. When the model generates an answer, entropy evaluates its confidence. If the result has low entropy, high confidence, it sticks to the plan. If it's high entropy, uncertain, it explores new strategies. This balance prevents overfitting and keeps learning efficient. The proof is in the numbers. SRFT achieved 59.1% accuracy on complex reasoning tasks, 9% better than traditional methods. It also handled out-of-distribution problems, completely new scenarios, 10.9% better. Imagine a model that doesn't just memorize answers, but adapts to unknown challenges. That's SRFT in action. Let's get technical. SRFT uses a dual-objective loss function that simultaneously optimizes for both SFT, minimizing prediction error, and RL, maximizing reward signals. Here's how it works. 1. SFT component. The model is trained on labeled data, learning to predict correct outputs. 2. RL component. A reward model evaluates generated answers, providing feedback to guide the model. 3. Entropy regularization. A term in the loss function penalizes overly confident predictions, forcing the model to explore uncertain regions. This creates a feedback loop where the model learns from both explicit examples and implicit rewards, mimicking human learning, where we combine structured knowledge with trial and error. Take this math problem. IA walks 9 km, stops for coffee, and the total time depends on her speed. When she walks at speed s, total time is 4 hours. At s plus 2 km/h, it drops to 2h 24 m. What's the time at s plus 0.5? Solving this requires setting up equations. 9s plus t equals 4. 9/s plus 2 plus t equals 2.4. Solving gives s equals 2.5 km/h and t equals 0.4 hours, 24 minutes. At s plus 0.5, walking time becomes 9/3 equals 3 hours, plus coffee equals 204 minutes total. But here's the kicker: SRFT doesn't just solve this, it generalizes. It learns the process of breaking down problems, not just the answer. So why does this matter? As AI tackles tasks like coding, scientific research, or medical diagnostics, reasoning is non-negotiable. SRFT's approach isn't just a technical improvement, it's a shift in how we train models. Instead of rigid, step-by-step methods, we're building systems that learn fluidly, adapting to new challenges like humans do. Next time you see an AI solving a tough problem, remember, techniques like SRFT are helping it think, explore, and grow, just like we do. Thanks for watching. If you want to dive deeper into the math or the code, check the links in the description. Stay curious, and I'll see you in the next video.